All right, so day 2 in our logarithmic properties, functions that spend a little bit longer. So first things first, evaluate each expression. Evaluate is a fancy way of saying solve it. So when we're doing these, for most of them, I'm not going to expect off the top of your head that you're going to know 7 to what power is 1 over 343. I'd even have to stop and kind of pause for a minute. So what we're going to do here is we're going to use change of base that we've talked about in both of these first two sections, which looks like this. We take the log of what we call the of value, okay, the larger physical number on the right, and divide it by the log of our base. And that order will never change, no matter what. So when we get here, I literally just log right next to the number 7, if you're using a graphing calculator like we are here. Get in my fraction. Divide. We got to hit log again. We got to have it both times, just like you see it here. And then we can grab the answer from there. And that really is all I have to do on the evaluate part. I don't have to do anything fancy. It's just always log of divided by log base. You're like, okay, that's not terrible. Then we start rolling into the stuff we were doing yesterday. Okay, expand each logarithm. Remember, expand means we're going to get bigger. So not only over on the board to your left, and if you're not looking at a board, I'm going to get it up on here too, we're going to be taking a peek at how we expand things, okay? We talked yesterday about 3 properties of logarithms: the quotient property, the product property, and the power property. The quotient property, if we see any fractions or division, we turn divide into subtract. The product property, if we see multiplying, we turn that into addition. So those are similar to exponent rules. And then the power property, if we get to that one, if we see exponents, they're going to turn into coefficients, into numbers in front. And so as we started to look at these yesterday, we're going to end up looking at number 5 and number 8 here. And what we noticed was there was only one exception to going out of order with our expand rules. This is the order that we like to go into. It keeps us out of the most trouble. And so the one exception to following the rules is if there's an exponent outside parentheses, like there is here in number 7. If that happens, my first step is going to be to go ahead and distribute that. And when we go power to power, we multiply. So we'll rewrite this. 3 times 5 is 15. And 1 times 5 is 5. Okay. So that's our initial problem that we're going to look at. Again, the only time we do that is the exponent outside the parentheses when we start. So now I start working my way down the checklist. So my quotient, division. I don't see any fractions. I don't see any divide signs. So we're not going to use the quotient one this time. We won't use all of them every time. Product. Do I see multiply? I do. That's going to become add. So here's how that looks. I write my log with my base, so my log 8, u to the 15th, and then when I see the times, that's where I'm going to put the plus in. And then I have to rewrite my log base 8, and then write my last term. So each time I do something in my list, I'm making more logs. I'm expanding. So far I've gone from 1 log, I've expanded it out to 2, but I still have 1 step to look at, and I might have 1 more thing to do. So the power property. Do I see exponents? Oh, do I see exponents? I see 2 of them. If I see those exponents are each going to turn into coefficients, okay, the number in front of log. So my 15 moves from an exponent to in front. My 5 moves from an exponent to in front. So if I've gone step by step like it is in the list, at this point I know I'm done. But if I don't, what I'd basically do is say, do I see any fractions? Nope. Do I see any more multiplying with a number and a variable? Not just in front of log. Nope. Do I see any exponents? Nope. And that lets me know that I'm done. But again, if I just do it in the order of expansion that we have here, I'll never have to worry about that because it won't never be finished. Okay. Number 8 was another weird one, so I wanted to step in here for a moment. Because some of you, if you see this radical, that's going to be like, woo, danger, danger. Maybe like, no need to be. So here's what that's going to look like. So we have z squared times x to the exponent over root. So sometime if I saw a square root, like just square root of x, it'd be x to the 1/2. Because I am going to have to get it into its exponent form to be able to do this with my logs. So I get that written in, and I go, okay, let's roll down the list again. Do I have any division? Do I have a fraction anywhere? Well, except for my exponent. But no, I'm not dividing anything. Do I have a product? Am I multiplying? Yep, right there. So I rewrite the first part, log base 4 of z squared. And then when the multiplication dot would be there, I put my plus. I rewrite my log. Okay. Plus disappeared. Now I've got 2 logs. I've expanded. And so my last step is to take my exponent, or in this case exponents, and swing them back down around to the front to become a coefficient. And I'm hoping that by the time we get done today, this is a little less muddy for you. But there's no reason right now not to either keep, if you've jotted down from the board already or from up here, that you just kind of follow that for a bit until you get feeling comfortable with it. Okay? So when we expand, those are the rules, and we're trying to make more logs, okay, out of 1. When we get to condense, everything kind of flips. The order that we do things in and the direction we go. So just kind of as a side-by-side here for a minute. When I look at condense, I notice instead of going quotient, product, power, now it goes power, product, quotient. And instead of going exponent to coefficient, it goes coefficient to exponent. Like literally everything is backwards. Instead of multiply to add, it's add to multiply. It's subtract to divide. And so when we start doing these, and I'm going to move this up just a bit. We still are fitting everything. So we'll take a look at some options that we've got here. So like if I look at number 9, I go, okay, do I see any coefficients? And again, that's the number in front. And I do. I see each of my terms here has a coefficient. Those are going to turn into exponents on my variable terms. So that 3 is no longer in front. It's an exponent. This 3 is no longer in front. It's an exponent. So then I look at the next one. I look, it says product. Add into multiply. If I see add, I see add. Okay, that's going to become multiply. And one thing I hadn't mentioned yet, when we're condensing, we're trying to smash it down. We want to get down to a single logarithm, just one. So now I look and I go, okay, so log base 9, I'm going to have x to the 3rd times, because again, plus became times, y to the 3rd. I went from 2 logs to 1. I smashed it into 1. There is no subtraction, so I don't do the quotient rule. But I know I've made it when I'm down to a single log, and I am. I'm going to move this down a little bit. So we're going to be moving up a little bit here. So let's say we roll with that on number 11. Same idea, same order. We're smashing it down into 1. We're condensing. If I see coefficients, they become exponents. If I don't see a number in front, no big deal. So that becomes the exponent on my x. I notice I don't see any pluses, so I'm not going to be using the product property. But I do see a minus, so I'm going to be using quotient, which turns that into divide. So x to the 6th minus becomes divide y, 1 log. So they can be short, they can be quick, they can be several steps, it just depends. And so the last one that I typically do here is going to be number 12, because number 12 just looks weird. You're like, what's up with that? So here's what's up with that. We're going to rewrite this one at the start, because we may not recognize that right away with this if we don't. When you have something over 2, it's like multiplying it by a half. So each of these fractions is really just a coefficient of 1/2, which is important for us to realize, because when we start at the top of our condense, first thing is all those coefficients, all those 1/2s are going to become exponents. We may run a little bit into number 14 here, but that's okay. So that 1/2 log base 4 of a turns into log base 4a to the 1/2 power. And here momentarily we will have b to the 1/2 power. And then we will have c to the 1/2 power, because all those coefficients plopped up in the exponent world. So then I look, I'm like, okay, product. Plus into multiply. Plus, plus, plus. You're like, do I have to do this 3 different times? No. I would actually encourage you not to do it that way. Because that plus just means I have d times a to the 1/2 times b to the 1/2 times c to the 1/2. I am down to 1 log. I'm done. So if you haven't, just make sure that somewhere between the notes yesterday or the sideboard or the ones I'm putting up here now, that you get your condense and expand rules down, so you've kind of got a guide to help you as you're starting to look through some of those. Okay, that's a real good kind of synopsis or review of what we did yesterday. So now, when we flip over to the back here momentarily, that's going to be what we did for the first couple of days when we were doing logs. And if we need to, at the end here, I will get the condense and expand stickies back up so you can get those jotted down somewhere to be able to help yourself out. But for the moment, we're going to flip over. We will come back. And we've got to remind ourselves a couple things on the graphing here. Okay, name the transformations. They help me out the most. Okay, transformations. Fancy way for saying the shift, up, down, left, right. And if it's been a little while, you know, it was last week at the earliest here. So just a reminder of what that looks like. And again, it's the value inside the parentheses. That's my left and my right movement. Again, the opposite of what we would think. And K is my up and down. Okay, that's something I got to work on getting into my brain here. So that's always going to be our first job. Name the shifts, name the transformations. So if at the start I'm kind of peeking at this to help me, that's okay, but we want to work on getting past that. So here, I'm looking at right 1 and down 4. So we've talked before about how I can get this other information that I need to do my graph and domain and range really without even using the calculator. So we're going to kind of make reference to that here. I'm going to do the first one here on the calculator, but then I'm going to chat through again how we could do it without, just to kind of get our memories jogged here a little. So we'll get into y equals. We'll type this one in. Pull up my chart, and I hopefully start to remember some things here. Like, when I'm looking where the numbers stop and the errors start, that's where my vertical asymptote is. And again, our vertical asymptote is kind of our do not cross line. It's a vertical line. But if I didn't have the calculator to look at, there's a real easy way to figure that out. Normally, that vertical asymptote is at 1. But if I have a left or a right shift, that directly changes this. So if I'd have gone left 3, this would have been x equals negative 3. If I'd have gone right 6, this would have been x equals 6. And that's always going to be true. So now there's another connection that goes with that. My vertical asymptote and my domain. It's always going to be some number to infinity. Well, what number is it? The same number as my vertical asymptote value, or the same value as my left or my right shift. That'll never change. And when we're doing logs, my range is always infinite. Period, end of story. And so if I have done it on my calculator, I can just use a couple of points they give me. So 2, negative 4, 11. Okay, 11, we're a little off the page here. 11, negative 3. But what if I don't have a graphing calculator? Do I have to wait and do it in class? Do I just skip the graphing part? What could I do? Here's what you can do if you don't have a graphing calculator. It's pretty straightforward. When we talk about graphing, we have these things called parent points. Okay, so my parent points are always the same. 1, 0, and 10, 1. You're like, okay, big deal. What does that mean to me? What that means to you is if you take your parent points and then you shift them. So if I start at 1, 0 right here, and I go right 1 and down 4, oh, I ended up at my first point that I saw in my calculator. Okay, if I start at 10, 1, and I go right 1 and down 4. Okay, I can figure out just by using the shifts, right and left moves my x, up and down moves my y, to get those 2 points where I don't even need the calculator. But most of the time we have enough time in here, you can just use the calculator. It's just an option for you though. So that's what that looks like. And just a little bit left down here at the bottom, and I will let you play with these for a bit. Rewrite each equation in exponent form. Okay, when we do exponents, it's always the base, the exponent is going to equal my answer. So, when I'm looking here, we know that's my base. We even call it that. Okay, my base is 18, so 18. My answer is always on the equals side. Oops, excuse me. My exponent is always on the equals side. And my answer is always here. We talked about this yesterday because we're trying to figure out 18 to what power is 324. And so if I wrote this correctly, mathematically it should work. I should be able to type in 18 squared in my calculator, and I better get 324. And I do. So I know I did it right. Now, if you type in something sometime, let's say you type in 324 to the second equals 18, that's probably not going to work out real well. And so I look at it that way. And so now when I go back the other way, and I'm trying to figure out, okay, now how does this work again? So it's log of my base. Okay, so we're going to do log of our base. My exponent goes on the equals side. And my answer goes right here with my log. And there's several ways to check this one too. Because on the front, we use change of base. So if I did this with change of base, log of 256 divided by log of 16. Okay? Log of the number on the right, the of divided by the log of my base. And again, I get a true statement. So if nothing else, I can kind of guess around a little bit until I get that statement right. But as you do more of them, as you get a couple practice ones in, that's going to get easier. So your job is to knock out the rest of these. Maybe this will help out with some of the ones we've been doing the past couple of days. But if you're getting stuck, let me know. The key is up front. So try a couple and check them before you go, I don't get this. Just try something first, and then we can see where you're at and get you some help with that.